This video is on section 3-5 on parallel lines and triangles. By the end of this video, you should know what the triangle angle sum theorem is and be able to use it to find missing angle measures in triangles. You should also know what the remote interior angles theorem is and be able to use it to find missing angle measures in a triangle. We're also covering 3 geometry standards, G.1.1, that you can identify and give examples of theorems, G.2.2, which is the new one, that you can use the triangle angle sum theorem to solve problems and justify your answer. And again, G.6.4 that you can prove and use theorems that use the properties of parallel lines cut by a transversal. Now, the first thing I want to discuss is how many lines parallel to line L can you draw through point P? And if you think about it, there's really only one that you can draw. That goes through point P that's parallel to line L. Because if you were tilted a little bit this way, you would eventually run into line L somewhere down there. Or if you were tilted a little bit this way, you would run into line L somewhere over here. So there's only one. And I know this seems like a trivial question, but the truth is that Euclid was a Greek mathematician, and he is thought of as the father of geometry. And what he did is he took 5 axioms, kind of like postulates, and based everything that we know about geometry on those 5 axioms. And the last one, the 5th axiom, was on this idea. And we have over time come to learn that what that means is that we're doing geometry on a flat surface. If it was on a sphere or some kind of a curved surface, then this wouldn't be true. So that leads us into the parallel postulate. Through a point not on a line, there is one and only one line parallel to the given line. Okay, it's the parallel postulate, and we'll use that later on in today's lesson. Okay, before we jump into the triangle angle sum theorem, I want at least to give you the definition of what a triangle is. And a triangle is based on a polygon. So a polygon is a closed shape with straight sides. Okay, and a triangle is a polygon with 3 sides. So the triangle angle sum theorem is that the sum of the measures of the angles of a triangle is 180 degrees. And I know this is something that you've used for quite some time, okay, that the angles in a triangle add up to be 180 degrees. But we're going to look at why that's true and actually prove this theorem in a little bit. But before we do that, I want to bring up the idea of an auxiliary line. Okay, in any diagram, you can draw a line wherever you want. Okay, you can draw a line here if that would help you in your proof, or you can draw a line here if that would help you in your proof, or you can draw a line anywhere that you want if it helps you in your proof. Okay, and that idea is an auxiliary line, and we're going to use that in the proof of the triangle angle sum theorem. Okay, we're given triangle ABC, and our goal is to prove that angle A plus 2 plus C is equal to 180 degrees. Okay, and our first step, although we usually start with the given, in this case we're actually drawing an auxiliary line as our first statement. Okay, now if we look at why this is true before we jump into what the proof looks like, we know that this we've drawn parallel to this. And from section 3-2, we know a lot about parallel lines, okay? Especially the pairs of angles that exist, okay? For example, angle A, we know would be congruent to angle 1 by the alternate interior angles theorem, because they're alternate interior angles, okay? Similarly, 3 and C are also alternate interior angles, okay? So they're also congruent. And the other idea that we'll use in this proof is if you add up angles 1, 2, and 3, you should get 180 degrees because they make a straight line. Okay, so we're going to use that idea along with some substitution to explain why the angles in a triangle add up to be 180 degrees. So let's walk through this proof. Angle PBC and angle 3 are supplementary because they're a linear pair. Okay, and what supplementary means is that the measure of angle PBC and the measure of angle 3 equals 180 degrees. Um, Statement 4 is that the measure of angle PBC is equal to the measure of angle 1 plus the measure of angle 2, so we can substitute this in to this part of the equation, and we get that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Okay, now if it were me, I'd probably be okay with jumping from here to here, and just saying it makes a straight line. But I guess in this proof, they've taken some more time to develop why the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So once we're there, we can then use some properties of parallel lines. For example, that the measure of angle 1 is congruent to, that angle 1 is congruent to angle A, and angle 3 is congruent to angle C. Okay, and that's by the alternate interior angles theorem. 7 is based on what congruent means, is the measures are equal. The measure of angle 1 is equal to the measure of angle A, and the measure of angle 3 is equal to the measure of angle C. And so we use some substitution, and we will plug this in here, and we'll plug this in here, and we get this statement, that the measure of angle A plus the measure of angle 2 plus the measure of angle C is 180, which is exactly what we were trying to prove. Okay? So the reason why the measures of an angle add up to be 180 degrees is for the exact same reason that a line is equal to 180 degrees. And that's the end of our proof. Okay, now using the triangle angle sum theorem, is that the measures add up to be 180 degrees. And we can look at some algebra questions. Let's see here. I'm going to start off with this triangle because I know two angles and I'm only missing one, okay? So in this triangle, the angles will add up to be 180 degrees. So if I think about, I'm just going to add up 43 and 59. 43 plus 59 is 102. So 180 minus 102 is equal to 78. Okay, so that means x is equal to 78. Okay, now if x is 78, then y would be supplementary to it because they're a linear pair. And so 180 minus 78 is 102. Okay, so now in this triangle on this side, I know two of the angles, I'm missing a third one, so I will add up 102 plus 49 and get 151. So 180 minus 151 is equal to 29. And so z is equal to 29. I think the question was find the values of x, y, and z. Here's x, here's y, and there's z. Okay, so just using the idea that the measures of an angle add up to be 180 degrees. Okay, now moving into the interior angles theorem. It might be the remote interior angles theorem. The triangle exterior angle theorem. An exterior angle, it's an important vocabulary word. An exterior angle is an angle formed by extending a side of an adjacent side. Okay, so if I take a triangle and I extend one of the sides, the angle that I create, not this side, which is a straight line, okay, the other side, okay, the other side, this side, is the exterior angle. Similarly, this is an exterior angle, and this is an exterior angle. Okay, now you would guess that interior angles are the angles that are on the inside, okay? But the remote interior angles, if you think about a remote for your TV, the remote is something you use from far away, okay? So the remote interior angles are the angles that are further away from that exterior angle. So these two are remote interior angles because they're interior angles that are far away from this angle. Okay, similarly 2 and 3 are remote interior angles to this exterior angle, and these are also remote interior angles to the exterior angle that's drawn. So the question is, how do you think the exterior angle is related to the remote interior angles? So how is this related to these two together? Okay, and if you think about, well, if this, whatever the measure of this angle is, then the measure of 2 plus the measure of 3 plus the measure of 4 is 180 degrees. Okay, also angle 1 and 4 add up to be 180 degrees. So if I take that and I subtract out 4 in both of those statements, I will find that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 1, and that gives us the triangle exterior angle theorem, okay? That the measure of an exterior angle is equal to the sum of the two remote interior angles. And the picture that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay, let's use that theorem. So in the picture of 1, this is equal to the sum of the remote interior angles. So it's equal to 80 plus 18, which is 98 degrees. And question B, what is the measure of angle 2? Well, I know that this is equal to the sum of 58 and 2. So 124 minus 58, sorry, 59. 124 minus 59 is 65 degrees. So angle 2 must be 65, so that 65 plus 59 is equal to 124. Okay, this video was on the triangle angle sum theorem, that the measures in a triangle, sorry, the sum of the angles in a triangle add up to be 180 degrees, and that you can use that to find missing angle measures in a triangle. Also, you should now know what the remote interior angles theorem is, that an exterior angle is equal to the sum of the remote interior angles, and be able to use that to find missing angle measures in triangles.